Somehow it's never working. Alright, I like this music. Nice, nice. Let's get this party started, huh? We want this window left. We want a code editor. So let's put that here. We actually want a debugger. So let's put that here. Alright, but not for this page. We want the debugger for another page, so let's keep this. Alright, welcome. Welcome to the show. The show where we will finalize a software as a service product, both project and product. And in this finalization, the most of stuff is already done. The most significant parts of functionality are already made. But in this finalization, you will have an opportunity to see how the project is organized, how these functionalities are dealt with, and you will see the most important steps in this finalization process. So you will have an overview of thinking mode, uh, problem solving approach, and in general everything that is needed to ship your SaaS. So unfortunately my last night's stream was not buffered in Twitch, so I need to give a overview of what we are making again. So let's do first just that. I need to start my servers, and for this I can immediately tell you that we have multiple type of nodes. So in typical bare bones web project we have the front-end node and the back-end node, and maybe some cloud services and whatnot. Here we have three types of nodes. So the front-end, the back-end, and one more type of server. And all three are in our control. So what is the story? Well, I personally was, let me see, where is my mobile? I personally was kind of frustrated, first time in my life, not first time frustrated, but first time regarding this, when we got a switch from the non-touchscreen phones to touchscreen phones. And these first touchscreen phones offered a keyboard that we currently know, so the one that we are using right now, but also they offered a transition keyboard, so you could type like on those old phones with buttons. So you could type on your by pressing the same button multiple times to achieve a letter. Now oh, lonely e-girl, sorry, welcome. So you could press the same button multiple times, times to achieve a keystroke. But I was thinking, and this was my disappointment, I was thinking how this is suboptimal. Yet, almost 30 years later, not 30, 20 years later, we are still using the same keyboard on our touch screens, which is basically a physical keyboard represented on the screen, and you are typing the buttons. And this leads us to one interesting point, that the user experience of technology is not optimized towards users, because in no way, in no theory of the world, uh, in no way, in no theory of the world, we are still using the same input as we used 50 years ago or 70 years ago, when the computers did not even exist. So the current communication between a user and a system, computing system, computer, is the more or less the same as typing was before computer even existed. So everything progressed so much. Everything progressed so much on in technology. We started with 1 GB flash drives. Now we have terabyte flash drives. So everything progressed so much, but we are still using the same input. This is impossible. So it was not in interest to fundamentally change and improve the user experience of using a computer system. Instead, the general approach was to bind people to devices. So instead of making devices empower people, we are binding them to devices in such a large way that even we have virtual identities. So, thinking about this, I designed a micro step, a micro way to better the communication between a human and a machine. One of the most striking and enriching points is that you cannot type on your phone without looking at the screen. Now, you can type on your keyboard without looking at the keyboard. You can learn touch typing, but you cannot type on your phone without looking. You could say, well, I can learn the order of the letters and type like this, but errors are unavoidable. And you could swipe, but swiping does not give unique solution, so the one swipe does not translate to a unique word. Sometimes there are multiple choices that you need to look at and choose. So, the idea is very simple. The idea is the idea is to type on your phone without looking at the phone. And then we want to use this new type of input as general input, not just for phones, but for many different types of devices. So, without further ado, let's start a server, development server for our React app, and see what the hell we have done so far. So the server is starting. Here it is. Alright, we have this fancy spinner that's in some way, later you will find out how, but in some way this spinner is fundamentally tied to how the system works. Alright, and we have these icons here for now. The keyboard icon, this paper, and this buttons. So if I go to keyboard, it tells me you could route input to a remote device. I have this text box here, and you can calibrate the keyboard to move a finger from center position to north position. This is the idea, to simply take into account the size of your hand, of your fingers, the size of your screen, orientation, and so on. I don't want to think about these things. You go and swipe from your comfortable resting position of thumb to the north, and this is calibrating your keyboard according to all these factors. So here I need to use my mouse to simulate the typing on a phone. Later we are going to actually use our phone to type. So if I calibrate here, then I get this circle of letters, and this circle of letters is basically meant for learning process. While you are learning, these letters and these labels are meant to remind you how to type, but later when you learn the movements, you will be able to type without watching. Now the movements themselves are very simple. So this movement means this one means just touch at the north position, at the up position, just tap there. Then you can double tap at the north. You can swipe from center to north. You can swipe from center to north and then 90 degrees left, or from center to north and then 45 degrees left. Also you could do 90 degrees right, 45 degrees right. Let's skip this row for now and let's see this row. So you could swipe from north to center. You have this circle here that denotes that you are going to center from north. You could go from north to center and then 90 degrees left, 45 degrees left, 90 degrees right, and 45 degrees right. So these are two groups of 6 movements. And if I go back to my keyboard here, I can actually calibrate it again and execute these movements. So here I have D and R. If I go from center to north, I will have DA. And now we can see in the text box here, DA. If I go from center to north and then 90 degrees left, I will get DE. Then I will get DI. Whoop, I missed with my mouse. Okay, something is not working. The demo failed. DI. Alright, DI. Then DO and DU. And for R, we go from north to center. So we go north center, this is RA, and so on. Left, RE, then 45 degrees left upwards is I, and then we have R O and R U. So this label means I have two letters associated with two groups, and I can write syllables associated with those letters. Alright, so that's nice. But let's see the other groups. We have much more arrows to go. So we did this group of from north to center, and this group from center to north. Now we can go to this group, which is a third group here, and the circle represents a center for this arrow. So if I go from north position left, then I am executing this symbol. And now if I check and see if I have something bound to this symbol, I have backspace. So I should be able to clear some typing. Whoop. I should be able to clear some typing when I make an error. So let's type something, DA, and then I go from north to left, and basically I remove A. Alright. Beautiful music. I like it. So that's about that. So we have a third group that goes from north, left, right, left down, right down, left to center, and right to center. Alright. And the fourth group, which is denoted with these arrows, is from north position to west position, from north to west then south, from north to west then center, from north to east, northeast, south, and northeast, center. So now we have 4 groups of 6 movements, and we can bind in this configuration here any letter, any snippet, or any macro, which is a series of shortcuts on the keyboard. We can bind any letter, multiple letters or multiple lines, or a macro to a simple movement. So to double the amount of movements we have, there is something called modificator. How do we execute a modificator? Modificator is executed by, so for example, we want to modify movement from center to north. If we execute movement from center to north, we get the A. But to execute this arrow that has this little stand here, which signifies the modificator, and we can see this signification of modificator in other arrows too, for example here. We can, on the example of center north, we can first tap at center and then in quick succession execute the movement. So if I tap and then go to north, then I execute the movement with modificator. If I want to go from north to center but with modificator, then I tap at north and then slide to center. Now the modificator is configured in such a way that it flips the order of consonant and vowel. So in regular order, the consonant is first. But if we put a modificator, then it is second. Alright. Now, why are we typing syllables? Well, first of all, the typing of syllables is only bound to this concrete configuration of the keyboard. You can make your own configuration and, for example, type 2000 of Chinese letters. You can map in 4 or 5 layers, because each layer of configuration has more or less 400 movements, and all of these movements are simple movements. So when I say simple, they are either straight or 90 degrees or 45 degrees. So you can do them without watching. Now, this concrete layout of the keyboard assumes that you are going to type syllables. Why? Well, if you are typing letter by letter, then your finger needs to jump from a position to a position. And jumps we do not like. There are 2 reasons why we don't like jumps. So the first reason is they are slow. It would be much faster if you just make a continuous movement with your finger than to jump around. And the second reason is they are imprecise. So you over jump or under jump and you get lost. So we want to eliminate jumps as much as possible. And for this reason, I thought, well, I can type syllables instead of letters, and this will eliminate around 30 to 40% of jumps, since most of the time we can type syllables. Not so often we have consonants together. So yeah, that's the idea of this concrete configuration. But the configuration can go beyond typing. It can map to, strictly say, in mathematical way, it can map a discrete set, any finite set of anything, you can map to movements. So for example, you can map emojis, you can map scripts, bash commands, you can map shortcuts of your favorite tool. If you are a coder, you will map shortcuts for coding. If you are a photo editor, you are going to map shortcuts for photo editing. So you could create a layer for GIMP or Photoshop or whatever you are using, and then execute possibly complicated commands, or maybe even scripts, Python scripts that are possible to be executed in these tools on the movement of a finger. So you could work from your bed, maybe, or even better, walking. You could work while walking and not watching at screen, just typing. Maybe you could type a message while not watching at the screen and driving at the same time, but still this is illegal. But just an example. If you are going to type a message while driving, it's better to type without watching at the screen than with watching. So you could watch the road. Okay, so this is the idea. Now we had this funny little thing here that's called route input to remote device, and now it says no remote devices are connected, and this is our third node that I mentioned before. So we have 3 nodes. We have our web app, this one, we have our backend, and we have our third node, which is another type of client that is meant to execute your input on a remote device. So we could start this type of client here. We have our development server here. But for this, I need to start this in another way. Let me see. Now I need to check some URLs that I'm using. For example, the remote connector should send, yeah, so it's going to take the location from the browser. So if I'm hosting from development server, it's going to try to post the input to development server. We don't like this. So maybe I need to start a backend server. Let's try like this. Not npm run start. Let's do like this. npx, which means node execute, node package manager execute. TypeScript node. I don't want to compile and build anything right now. Skip the configuration of current project to not give me warnings bound to create React app. And then go to source, go to touch keyboard version 2 and go to backend and start it. Now backend probably needs some environment variables, so we are going to pass them. Maybe port, it needs port. Alright, so I can say here port equals to 3151 and start this. Okay, we have our server running. Now we want to access the app that was previously built, front-end app that was previously built through this server, not through development server. And here it is. And now it's going to post the input to backend server. Now we can start another type of client, the controller client. It's called the controller. And we can actually say device name is home PC, and then start with same in the same way. Skip project, start source touch keyboard version 2 controller here. And now we have our controller device. So now we need one more step to start this. We need to forward our backend server publicly. So let's do downloads. Let's discover our ngrok place, and here run the ngrok on http for our 3151. And now we have this. So now I can access this from my mobile device. But let's first send it to myself on the mobile. Here it is. I just sent the link to myself. And now I can access this on the device. So if I open the link, come on. Okay, here we are. If I paste this link that I just received and go to this I will get my app. Now let me see if you see this at all or not. Huh? Alright, so I have this app on my phone. Now I can go to keyboard and go to this route input to remote device, and here I have my home PC because we registered a controller node, and then I can choose it so the input is routed to this PC. And now if I focus my Visual Studio Code here on the PC and try to type here, I will get, let's calibrate the keyboard and let's execute one syllable, and I got the typing on the screen, which is remote control. Now I'm giving you 1,000 reasons to learn this. It's basically just as hard as learning touch typing. You can learn this touch typing, but it's touch typing for touch screen. Currently we don't have something like this, I believe. Maybe I'm mistaken, but as far as I have seen, there is a way to draw letters, individual letters, which is insanely inefficient compared to this system. This system could achieve 40 words per minute for not extra speedy hands. And 40 words per minute is the exact same speed you have for typing with 2 thumbs watching at the screen. So you have the exact same speed without looking at the screen. And if you are one of those with speedy fingers, you could go even further, which is nice. Alright, so we have our remote typing and we have touch typing for touch screen. Now, not everything is done. I showed you what is done. What is not done? Well, first, I did not develop my muscle memory for this. I'm not still using this for my work, for coding, and this will be the first step. I want to make this usable for coding, so I can use it on my day-to-day work. So to do this, we actually need to make these macros executable. Now, we can make macros. As you can see, I have made a good chunk of macros here, and we have these letters A, S, C, and O. A is for Alt, S is for Shift, C is for Control, and O is for OS button. So is it Windows or Command or Super on Linux, whatever you have, let's call it operating system button. And then you define these macros, and then we want to be able to bind this macro to a movement. And once I execute this movement, a macro should be executed. So I can swap screens, execute shortcuts, and so on from typing on a touch screen. Now, if I choose a movement here, I can see the documentation for this movement, but the arrows are actually pretty intuitive. You start from north and go right. And then I can choose if I want my macro to be a text from a text area, or my movement to be a macro. So a movement can be a macro or a text from text area. Alright, and now I can choose, for example, Control Tab to change a tab. And now this Control Tab is configured here. But if I go back, this was the movement, but there is no configuration. For this we need to add a Redux slice for layers, we need to differentiate between layers and configurations. So layer is just configuration is composition of layers. One configuration of the keyboard can have multiple layers. Then we need to enable transition from layer to layer, and pretty much that's that. I believe this we can do pretty fast. So this is the current situation. Now, who would like to use this is a good question, and I believe there are actually a lot of people that would find this useful. I got the data that 90,000 people searches touch typing each month. So if you are interested in touch typing on a regular keyboard, there is a good chance you are interested in touch typing for a phone, because probably you are using your phone more than your keyboard. Then you could obviously be a power user and configure a lot of macros and leverage contextually aware input, because this controller node can read the context of your operating system, and it can know on which operating system you are and determine which inputs are possible. It can know what windows you have open, and so on. Let's not develop this idea any further about contextually aware input, but just state that it is, and then you can be a power user that works from bed typing on a phone, on one PC or another, or maybe even something else. So that's that. And there is another great area of usage. It is VR. If you are wearing VR, you for certain don't want to stare at your phone to type something. If you are wearing a VR headset or glasses, then certainly you want to be able to type something without looking at screen or without gesturing with your hands through air or something. So it could be useful to type on touch screen without looking. Another thing is accessibility. I can type without looking, so some people have vision problem, and they can receive another kind of feedback, maybe audio feedback or haptic feedback or whatever, and they can type with using only one finger without looking. So the accessibility is pretty nice. So there are people that I believe that would like to use this, and this is why we want to wrap this in a product. So the goal is to wrap this in a sellable manner, and for your viewing pleasure, you will see most, not all, but most of the intricate details regarding this. So the day when this service meets its success, you may have an idea how to replicate. This is the introductory video, and it was mostly talking. But in the next stream, in the next video, we are going to actually code in can make these macros possible. So I will see you there.